Okay, part D. He says, to estimate the value of alpha, Alicia considers a situation where there are no sharks and the initial macro population density is M0. Write down the differential equation for M that models this situation. Now, these were the couple differential equations we were given at the start, and he said that the alpha M was the growth rate of the mackerel without the sharks. If there were no sharks, it would just be dm dt equals alpha M, and then we subtract this beta ms, which is essentially these are the mackerel. This is the rate of death of mackerel, if you like, because the sharks are eating them. So if this didn't exist, we'd just be left with dm dt, and if that won't exist if there were no sharks, dm dt equals alpha M. So that's all they want for part 1. For part 2, show that the expression for macro population after 2 years is this. So essentially, guys, he's saying solve this differential equation. Now we can solve this by separating the variables. So what I'm going to do is this is a separation of variables differential equation. I'm going to do dm over m equals alpha dt, and then I'm going to integrate both sides. The integral of 1 over m is ln m, and the integral of alpha dt is just alpha t, because this is a constant, and then plus c. Then m is equal to e to the power of this, e to the power of alpha t plus c. And then we can do this trick, guys, that I hope you've seen before, and if you haven't, it's this. I can turn this into e to the alpha t times e to the c. So this is a constant, but this is just a constant. E to the c is just a constant. So I'm going to call it e to the power m equals a e to the power of alpha t, where a is e to the c. So a is just some constant. And then I'm going to find a by saying when t equals 0, m equals m0, because it says the initial population is m0. So when t is 0 at the start, m is equal to m0. Then I can sub this. I'm just going to come up here, guys. I'm going to sub these into this. So m0, m is m0, equals a e to the power of alpha times 0, which is just e to the power of 0. A is equal to m0. Therefore, subbing this a into this, m is equal to m0 e to the alpha t. And that is what we were asked to show. So I'm just going to write q, e, d, shown. Okay, that's part 2. Finally, part 3. Alicia estimates that the macro population density increases by a factor of 3 every 2 years. Show that alpha is that. Okay, so little bit of a trick to this. The macro increases by a factor of 3. So she doesn't tell us. We don't know what the initial population is, and we don't know what the population is after 2 years, but we know that it increases by a factor of 3. So what I can say is at t equals 2, so 2 years, m is equal to 3m0. So this is the key to the whole question. When t is 2, m is 3m0 because it increases by a factor of 3 from the initial population, if you like. So it'll be 3 times this. If the population was 1,000, now the population is 3,000. And then I can sub this into my differential equation. So instead of m, I'm going to put 3m0. m0 here is fine. E to the power of alpha, and instead of t, I'm going to put 2. Now, guys, do not make the mistake of subbing in 0.549 in here and showing that it's equal. You can't do that. That is not good enough for a show that question. Even though you'll get the right answer, you haven't shown that this is the only answer, if you like. So you have to, basically, this is the answer and you have to get there. You can't use the answer in your proof. Again, hopefully you should know that. So m0s cancel. I'm left with e to the power of 2 alpha equals 3. 2 alpha equals ln of 3. If I remove the, I'll just bring in logs, and then alpha is equal to ln of 3 over 2. And I'm guessing, guys, that ln of 3 over 2, well, let's see what it is. ln of 3 over 2 is menu number, convert to decimal, 0.549306, 0.549306, which is approximately equal to 0.549, which is what we wanted to show. So that is also shown. Okay, part D done.